Here we have AP calculus AB problem. Okay, let's go to the question. The graph of f of x equals to x times ln x a whole square as a point of inflection at. Okay, so for the given function, we have to find the point of inflection. Okay, the point of inflection is nothing but the one at where the graph of the given function will change its concavity. That is, it will change either from concave upward to concave downward or concave downward to concave upward. Okay, now to get the point of inflection from the given function, usually the value of x when f double prime of x, that is a second derivative of the given function, either will be equal to 0 or it will be undefined. So now we have to get the second derivative of the given function to get the value of x at where we have the point of inflection. Okay, now let me take the given function as it is. That is f of x equals to x times ln x, that is natural logarithm of x a whole square. Okay, here let's find the first derivative of this one, that is f prime of x. Okay, now to get the first derivative of this one, we have to consider the product over here. That is x and this ln x whole square are multiplied, and both of them contain variable. Whenever two terms are multiplied and both of them contain variable, to get derivative of that product, what we have to do is we have to use the product rule. What is product rule? Let's consider the product of two variables u and v. And if I want to get the derivative of this product, what I have to do is I have to keep the first variable u as it is, get the derivative of the second one. Now I have to take positive sign. Now I have to get the derivative of the first one and keep the second one as it is. So the same thing I have to do over here to get the derivative of the product of these two terms which contain variable. Okay, now I have to keep the first one as it is, that is x1 as it is, and we have to get the derivative of the second one. So when I get derivative for the second one, first I have to do derivative for the x1 and 2 using the power law of derivative. That is, I have to bring this x1 and 2 in front of the variable. Now I have to subtract 1 from the exponent, that is 2 minus 1 is just 1. So ln x raised to the first part is the same ln x. Okay, so far I have completed derivative only for this exponent 2 using the power rule. By chain rule, I have to do further derivative of the base ln x. The derivative of this ln x is just 1 over x. Okay, now I have completed this particular part, that is u times v prime. I kept the first one as it is and I got the derivative of the second one. Now I have to take positive sign. I have to get the derivative of the first variable. The derivative of x with respect to x is just 1. I have to keep the second one as it is, that is ln x the whole square. Okay, here this x and x will cancel out. Then I'm getting f prime of x equals to 2 times ln x times 1 is still 2 ln x positive. 1 times ln x whole square is ln x the whole square. Okay, now what I have to do is I have to get the second derivative of the given function, that is f double prime of x. Okay, now when I want to find derivative of this one, I have to consider the constant which is multiplied by the variable part. When I find derivative, if there is a constant multiplied by the variable, I have to keep the constant as it is and I have to get the derivative of the variable alone. So here when I get the derivative of this part ln x, I am getting 1 over x. Okay, now let's do derivative of this one. So here I have to do derivative for the exponent first using the power rule. So for that we have to bring this exponent 2 in front of the variable. Then I have to subtract 1 from the exponent. When I subtract 1 from the exponent 2, I'll be getting 1. That is ln x raised to the first part. It's still ln x. So far I have completed derivative only for this exponent. By chain rule, I have to do further derivative of this base ln x. When I do derivative of this ln x, it will just become 1 over x. Okay, then we get f double prime of x equals to this 2 times 1 over x can be written as 2 over x. And here when I multiply this 2 ln x and 1, I'm getting 2 times ln x over x. Okay, now we are adding two fractions with the same denominator x. So we can take the x as a common denominator. Then we have to add the numerators. That is 2 positive 2 times ln x over x. Okay, now to get the second derivative critical number, that is we have to find the value of x for which the second derivative is either equal to 0 or it is undefined. Okay, so here we can get the value of x for which the second derivative is undefined. When I take x equals to 0, the denominator becomes 0. The denominator becomes 0 means that the fraction will become undefined. That is, the second derivative becomes undefined. So x equals to 0 is the second derivative critical number, but we cannot consider this one because for the given function, 0 is not a part of the domain. Because here we have ln x, in this ln x, we have x as the argument. So always the argument of a logarithm has to be positive. It cannot be even 0 or negative value. So always it has to be positive. So the domain of this given function is x is greater than 0. It cannot be 0. So but here we get x equals to 0 as the second derivative critical number. Since 0 is not a part of the domain of the given function, we can reject this one. Now what we can do is we can equate this second derivative to 0 and solve for x. Let me do it. So second derivative f double prime of x equals to 0. When this one is 0, then the stuff that is equivalent to f double prime of x also must be 0. then I'm getting 2 positive 2 times ln x over x equals to 0. Okay, let me multiply both sides by x to get the denominator x over here. This x will cancel out. Then I'm getting 2 positive 2 times ln x equals to 0 times x is 0. Let me subtract 2 from both sides. When I do so, this 2 negative 2 will cancel out. I'm getting 2 times ln x on the left side. On the right side, 0 negative 2 is negative 2. Okay, let me write the same stuff over here. 2 times ln x equals to negative 2. Let me divide both sides by 2. When I do so, this 2 will cancel out. I am getting ln x equals to negative 1. Okay, how do I have to solve for x in this equation? So for that, what we have to do is I have to convert this equation to exponential form. Already this equation is in logarithmic form because on the left side, the part which contains logarithm. So this logarithm equation has to be converted to exponential form. For that, we have to consider the part which contains logarithm. Clearly, this part contains logarithm. So what is the base of this logarithm? Actually, whenever we write the spelling ln, it represents natural logarithm and its base is e. Actually, we don't mention base e for ln, but we have to understand the base of a natural logarithm is e. Okay, now to convert this equation to exponential form, you just consider the logarithm along with the base on the left side. So it has to be moved to the right side of the equation. When it is moved to the right side of the equation, we just have x on the left side. When we move this ln base e to the right side of the equation, we have to ignore this natural logarithm. We just have to consider only the base e on the right side, and the value which already exists on the right side will become the exponent of this base. Okay, now I got the value of x. Okay, now to make the exponent negative and as positive, what we have to do is we have to move this term to denominator. So we can assume there is 1 as the coefficient of this e to the negative first power. When I move this one to denominator, we'll have 1 in numerator. And also when it is moved to the denominator, the negative exponent will become positive. That is e to the positive, e to the raised to the power of positive 1. But whenever the exponent is 1, we don't have to mention. Anyways, I got x equals to 1 over e. I got this value of x by equating the second derivative to 0. Usually the value we get for x when we equate the second derivative to 0 represents a point of inflection. So that is why point of inflection for the graph of the given function at x equals to 1 over e. So we find 1 over e in answer choice B. The correct answer choice for this question is B.